Everyone, I'm Aastha, and I have been working with React for over a year now. And I want to introduce you all to TypeScript and how to get started with using TypeScript with React. So let's begin. So there are certain prerequisites for you to take the most out of this talk. So let's go through them first. So I expect familiarity with React, and that is all because React is a JavaScript library. So I expect you know React and JavaScript. And this is the structure of the talk. So first we'll be going through the basics of TypeScript because I don't expect you to know TypeScript, and we'll be going through this together. One point that I need to make here is that this is going to be non-exhaustive. That is, I'm going to cover most of the things that are going to be used generally by you. But then there's always more, so you can look that up later. And after that, we'll jump to using TypeScript with React. So let's get started with TypeScript basics. Okay, so the first thing that I want to talk about is variables, right? We use variables all the time. So you can declare constant variables in JavaScript also, and you can, so all the things that you can do in JavaScript, you can do them in TypeScript, but there are certain benefits. So I'll go through them and all the things that you can do here. So the first thing that I want to talk about is constant variable. So for example, this is a constant variable that you have. Now you want to make sure that you do not override this with any other value. So for example, if you do something like this later on, TypeScript is going to catch this for you without you even running the code. And this is very important because in JavaScript, so I have a JS file here. So for example, I have a value 12, and now if I try to do this 15, it does not get mad at me. And until and unless I run the code, it does not tell me that there's something wrong with it. Once I ran the code, it told me that, hey, you are trying to reassign a value to a constant variable. So that's a benefit that you get here. The other thing is that you can also declare variables that can change due course of time with the help of let. So for example, this is 1 and later I want to make it to 2. But what is happening in TypeScript is that it's type checking with JavaScript. So TypeScript is basically JavaScript with static type checking. So what's happening here is that it has implicitly realized that this variable is of type number. So I can only put numbers in here. So for example, if I try to do something like this, it's going to get mad at me. It's going to tell me that type string is not assignable to type number. And there's one more quick tip. I think hover is really very helpful when you're working with TypeScript. The messages are very clear and they tell you what exactly is wrong. So this is not something that you can do. Now, in both of these examples, right, TypeScript actually inferred the type for us. What if we want to declare a specific type? You can do that as well, which is like this. So you can tell it that, so this is a syntax. So you can say that this is going to be a string. And now if you try to do something like this, it's going to get mad at you. The other thing is which is really interesting is that the type checking is kind of strict, like it's which is important as well. For example, in languages like C++, right, if you try to print truth if you try to print true, you'll get 1, and if you try to print false, you'll get 0. That is it's okay if you know just check 1 or 0, but here that's not the case actually. If I decide that this variable is going to be a boolean, I cannot just go ahead and be like, now it's a number. No, that's not how it works. You cannot assign a number to a boolean. Similarly, if it's 1, I cannot assign true here. So this kind of type checking is done by TypeScript for me. So that's kind of interesting. So we did cover variables. Next up is objects. We use objects a lot. So I thought we might go over them as well. So there are two ways you can declare objects. So one is when you're declaring them on the fly. So I just declared a key value pair here. And again, this was implicitly inferred. The type of the object, say, it tells me that A is a number and B is a string. Right, this is something that TypeScript does for me. And I cannot do something like this. So there is no property P that I declared here. So TypeScript is telling me that, hey, there is no property P and something's wrong here. Whereas JavaScript does not do that for me. Let's just simply copy this only. And if I try to do something like this, and now if I want to do .p, for example, JavaScript is not mad at me and it will print something if I run this file. Let's see what it does for me. Oh wait, we still have an error here. So yeah, so it says undefined. Now you might have seen this, you might have even actually experienced this, that sometimes you access a property that is not there, and then on the website when you go for checking you say, oh, undefined, where did that come from? So these are the kind of problems that you might face, whereas TypeScript just catches them on the fly for you. The other thing is that, so here this was inferred by the language for you, but you can also declare. So for example, I can say cat type, and this is going to be the name, age, breed, whatever, and then I can certainly access the type. So this is something called interface. So interface is a type alias, which you'll be using a lot. So this basically is a type. So for example, if I say const high, uh, this is going to be a string, for example. um, there's something is equal to, so for example, here I tell that this is the type. So similarly, if I want a type something like this, which is an object, there are multiple key value pairs, so I can declare that with the help of interface. And this is how I can assign values and use that type. uh, and again, you cannot access a type that does not exist, because it just tells you that hey, the property pos does not exist. So that is there. Also, you cannot tap into types that do not exist. So for example, here it very specifically tells me that there's no such thing as doc type. Whereas if you were to do something very fishy here in my JS file, for example, if I'm trying to say uh, greeting dot hello, there is nothing called greeting in this file, and definitely not a property hello. But if I try to run this, it'll run for me and it'll say that this is undefined. So that is another thing. Now what I want to talk about is functions. So you're going to use functions as well a lot of the time. So this is an arrow function. You can also use this type, which so arrow functions came in ES6, but you can also use this syntax. I generally prefer arrow functions. So what you do here is you define the types uh, of the variables, that of the parameters that you're going to take in, and then you can say what you're going to return. What happens with this is that you cannot do something like this, like you cannot simply give in a string to the function, because it expects numbers like this. And similarly, you can define a type. So for example, I have a multiply function type. A is a number, B is a number, and it returns a number. And then I can use again the same syntax to say that this is the type. In fact, what would be better is that if I call this numfunc, that is a numerical type of function that would take two numbers and return two numbers. So for example, and return a number, sorry. So for example, if I wanted to do something like this, and I say p comma q, and this one returns p plus q. So it works, and that's cool because we're using the same type. So that is also there. That's something you can do. The other thing is, so you might be wondering that, hey, what if I want this to be a string or a number? What if I want both the types? What if I want more than one type? How do I do that? Well, TypeScript allows you to do that as well, and this is called the concept of unions. So you can have a type something like this. So what this tells TypeScript is that, hey, the num string variable can either be a number or it can be a string, but no other type is allowed. So for example, if I do boolean, it'll get mad at me because that's not allowed. That is something that can also be done. And other thing is any. So this is something that is like JavaScript. For example, you can assign a variable any kind of type. So here, if you tell that anything is any, it means that you can assign it a number. And when I mean number, I mean a number that is an integer or a decimal number. Both are allowed. Or string or boolean, it can be a function, it can be anything, as the name suggests. And there is another thing that happens. So, for example, if I write a function and I do not tell what the parameters are going to have the type as, so what happens is that it infers for me. It says this is going to have any type. So I can pass in anything here. But for example, if I say no, this can be string only, the other can be of any type. So then it gets mad when I try to pass in numbers. So that is other thing. So those are all the things that I wanted to cover for TypeScript basics. Of course, there's a lot more, but this is more than enough for us to get started. In the presentation, I have some snippets for you to go through. Don't worry, I'll share this presentation and you can always refer to them. So the next thing that I want to talk about is actually using TypeScript with React. So let's get started with that. I already have a project that can handle TypeScript. So the thing is that you'll have to have your project be able to handle TypeScript. Now, how to do that? So either you can use a boilerplate. So with Create React App, you can use this command and directly you can use a boilerplate. And I would recommend this when you're starting out. But if that is not the case, if you're, you know, changing your project, if you already have a project in JavaScript and you want to now convert it to a TypeScript project for static type checking and all the benefits that you get with it, you can go to this link. This is actually official documentation from Create React Apps, and you can see how you can set up TypeScript in your React app. So let's see. The first thing that I want to talk about is this. This is something that is new here, and again, it's a type. So what is React.fc? If this were not here, this was your regular component. But this is here, and what this does is this tells everyone. This announces that hey, this is a functional component, and that is what this type is. This type reacts give this to us. So react.fc is a functional component. Now the other thing is that we have this card thing going on here, and I'll show you how this looks. This is how this looks. This is the card and there are some props going on. So let's actually see what's happening. So let's go to the card file. So everything looks normal here. Like apart from react.fc, it's basically JavaScript. Like there's no much difference that you can see as such. But in card.tsx, you'll be able to see the differences. Oh, and one more thing that I missed. So you can see that there's a difference of the file extensions. So when you have a regular TypeScript file, it's a .ts extension. But if you want to have JSX elements, then you need to have a .tsx extension. So that is there. Now here the action begins. So the card is actually this thing. This is the card that we have, and let's see what's going on. So we have some props. So we do use props in our components, right? So for example, there are a lot of things here. So you can declare an interface at the top, and the general practice which is good is to actually say what kind of props this is. So these are card props. I have a name and I have an age. What I do here is that react.fc, this is the type, and it's going to take these card props. And then I use them as is, like regularly, the way you do. What's interesting is that what this gives me is that now, for example, it might happen that I forget to give this prop. Now TypeScript is showing me some errors. It's saying property name is missing. It's already telling me that this has happened, which does not happen with TypeScript. It does not tell me that I've missed a prop, whereas TypeScript does that for me. And there's one more thing that you can do, which is quite interesting. So you might say that I want my code to be modular and I don't want to create, another component just because I want to maybe have a property color here. Right. And I totally agree. So TypeScript, it allows you to declare optional optional props. So you can just say optional properties. This is an optional property now. So with this question mark, it has become an optional property. So now if I don't pass color, uh, TypeScript is not mad at me and I can pass it as well. And let's see what other things this can do for me. So for example, I use it here and I say I like your um, favorite color, and let's say which is, and so if this is not there, and if I just simply say color here, then this might be undefined, right? But that is not what something I want. I want this to be like, if it is there, then I want this, otherwise I don't want this. So what you can do here is that if someone passes you this prop, so what you can do here is you can write some TypeScript here. So if color is there, then I want to say which is, um, otherwise I don't want to say anything. So maybe just an empty string. And now if I don't pass anything, you can say I like your, you can see that there's I like your favorite color. But now if someone passes this, you can see now that which is pink is now visible. So you can do all those things here. So you can this pass this also, not pass this also, and use this component again and again. So we discussed how to pass props, and how to pass props and how to use these specific components. The other thing that I want to talk about is hooks. You're going to manage a lot of state. So let's talk about that as well. So I have a counter component here. So what it does is it simply counts, and thing that I want to talk here is used. So this is going to be the most used hook in your app, and I would suggest that you practice with types and how to use it. So for example, I so here in the card file, we saw that the interface, it had we had an interface here, right? But in the counter, we did not declare that. So what you can do is, if you don't have much properties, you can simply declare your props here as well. But if there are many of them, then you can create an interface like this. That makes it more readable. But since there was just one prop that I wanted to take, I declared it here itself. Now, what happens is in useState is it infers a type for us. So currently it already tells us that this is a number, and it infers it. So for example, if I now want to show the counter here, thanks VS Code for importing it for me. So again, I'm not passed start. So for example, now I say that start with 2, and let's see how everything looks like. So it works as expected. So what happens is that I'm saying that this is the prop that I want. The type is of number, and I am going to uh, change it on click. Now again, let's do some fun here. Let's make this optional. So for example, if you make this optional, right, now there's some interesting thing that is happening. TypeScript gave me an error here. It says object is possibly undefined. Now this is great, because for example, if you don't pass a prop in some component, everything will break in some cases. But here TypeScript does not let that happen. It tells me that this is possibly undefined, and that I should take care of this, that I should do something about it. So let's do something about it. Let's say that if start is passed, that is, if start is there, then we want to set count to start. Otherwise, let's begin everything from 0. And okay, I still have an error here. Let's see what. Okay, let's try this in. Let's do this here itself, because of course this will not work. I need to do it here only. Set count. uh, Sorry, I need to do it here only in the used. So if start is there, then I want to use start. Otherwise I don't want to use start, I will use 0. And now the error is gone, because it knows that there is a certainty that a value will be there. If start would be passed, then start would be there, otherwise 0 would be there. So for example, if I don't pass a start value now, then the counter will start from 0, as it does. So we covered a lot of things, and that is all that I wanted to cover. There is again code snippets here, and I will be sharing this presentation so you can have a look at it. These are a few resources that I find really very useful. So when you're just getting started, use these for reference. For example, TypeScript, officially they have this section in their documentation, which is TypeScript for JavaScript programmers. Then there's documentation in for React, where there's a specific part where they show how you can use static type checking with React. And there's also TypeScript handbook, which TypeScript themselves they released it, so you can have a look there as well. And the other thing that I want to recommend, uh, oh, the website open. And the other thing that I want to recommend is this presentation and this talk. And that's about it. What I want to say is, what are you waiting for? It's time to power up your React apps with TypeScript, with static type checking, and have fun, make wonderful things with it. And that's all. Thank you. Connect with me on Twitter and GitHub to stay posted.